Hi guys, this is the demonstration for question number 7 and 8 in the Christmas break problem set, and they are all being 4-star questions and should be fairly challenging, but I trust you guys, you could all do this. All right, question 7 is actually a question about the probabilities, and I don't know, they are tending to not include these kind of questions now, but it is a fairly good question, so we still include this in the problem set. All right, let's see this one. So the question says that is a box containing 20 golds, 10 silvers, and some bronze medals. So for the question, like if it's having some bronze medals, I would have a no unknown number being x here in this question. So this would make the thing easier. So the probability that if you select a ball from the container, the probability that it is gold is 20 uh, over 30 plus x. If it's silver, that's 10 over 30 plus x. And for bronze, it's actually x over 30 plus x. Um, all right. Sorry. Then we would have to consider the two situations of randomly selecting two gold and two silver medals with replacement, and the random selecting one gold, one silver, and two bronze medals with replacement. When you're actually having the two gold and two silver, like you might be applying this equation, which you are multiplying all their chances together, but this is not the correct one. For instance, when you're having 2S and 2G, there would be several different situations. Like you could have SSGG, but you could also have SGSG or SGGS. This also applies if you have the G first. So uh, GGSS, GSSG, and GSGS. So there are actually 6 situations. Or actually, if you have learned about combinations, you could actually do it in another way that you don't need to list them out. Have C22, where you are having two balls and they should be silver, and then you have two balls that they should be gold. So that's C42. So like I've included the calculations here, like about the factorials, which C12 is 2 factorial divided by 2 minus 1 factorial times 1 factorial, that's 2. And for C42, that's actually 4 factorial divided by 4 minus 2 that factorial times 2 factorial, which is 6. So, well, if you have C22, that's like 2 factorial divided by 2 factorial, that's 1. Like, so for this one, you have 6 here. And also when you're considered that it has 1 gold, 1 silver, and 2 bronze, you have C11 multiplied by C21 multiplied by C41. This gives you 1 multiplied by 2 multiplied by 6, giving you a 12. All right, so when you are actually multiplying their probabilities together, you should also multiply what you have here about the combinations. This actually make this actually work. So when you're having 100 divided by 30 plus x thing squared times 40 divided by parenthesis 3 plus x squared and times 6, this actually gives you this number. And the same way, when you're multiplying for the probability of the second situation, that gives you 20 divided by 30 plus x times 10 divided by 30 plus x times x squared divided by 30 plus x squared times 12. That gives you this number. And obviously, as the question is stating that they're having the probability equals the probability. So in this case, it's you just need to know that they equals each other. So actually, if they are the same, they have the common denominator. So that's actually their numerator are the same. So that means that's 240000 equals 2400 x squared, meaning that x squared is 100. So that gives you the x is 10. So there are actually 10 bronze balls. So the answer is 10. Question 8 actually explores a little bit about triangles, about their certain properties. For this one, it gives that you have three integers and one is 2015. So fairly assumption that is a question from 2015. And when you're having that, you could just assume that you have two other numbers, well, something weird just happened. Whatever, let's continue. So for here, it gives you that like we could actually set the other two integers being a and b. And if we're already setting these integers and we know that they are different integers, we could just make a smaller than b smaller than 2015. Actually, as you are wanting, like as you are expecting the two other integers being the least possible sum. So it's fair that you make them smaller than 2015. So after this, you would just need to find the side of the triangles. So there are 1 over A, 1 over B, and 1 over 2015. If you know that A is smaller than B, smaller than 2015, I feel like it's a common sense that you know that 1 over A is greater than 1 over B, greater than 1 over 2015. So when you're having a triangle, what you should know about is a certain property of triangles. That if you have a triangle, that any two sides of the triangle should, like their sum should be greater than the third side of the triangle. This is how this works. And the actual definition is any two sides. But in this case, if we're already knowing that 1 over A is the greatest side, it's the longest side. So like for all these three inequalities, what you really need to consider about is only this one, because you know that 1 over A is greatest and the other two have to add up greater than it. So after some straightforward algebra conversions, like you move 1 over B onto the other side, and also you make them having a common denominator and make it another fraction. So you result in b minus a over ab is smaller than 1 over 2015. So for here, like when you are seeing 2015 here, 1 over 2015, like you know that b minus a, as you are saying that b is greater than a and they are all integers, so you know that b minus a is greater than 1. So that means that a times b. So for this case, that means that b squared would be greater than 2015. And as you might know that 44 squared is actually 1936 and 45 squared is 2025. So that means that b should be greater than 25. B should be greater than 45 or equal to. For this, you just start testing it. So you will first start with b equals 45, and you know that a is smaller than 45. And when you're actually starting from a being 44 and b being 45, you have 1 over 44 minus 1 over 45. This gives you 1 over 1980. That is definitely greater than 2015. And when you have a smaller a, that means that this will be like 1 over 43, 1 over even 1 over 1. This number is going to increase, and this will also increase. So this will always be greater than 2015. So this does not apply for this situation. So you would consider B being 46 when B is 46. So A has to be less than 46. So in this case, you have 1 over 45 minus 1 over 46. This actually gives you 1 over 45 times 46. That's 1 over 2070. And as it has a larger denominator, this is actually smaller than 1 over 2015. And this actually applies here. And this will give you that A plus B equals 91. So that's our least possible sum for now. but you also need to like consider like theoretically, you need to also consider a less than 45. If a is less than 45, we will just grab the greatest number, which is 44. When you have 44, 1/44 minus 1/46, this gives you 41 over 44 times 46 divided by 2. This actually gives you 1 over 2012. That's greater than 21 over 2015. So this does not work. So for here, you will just know, like for here, you know that a plus b, their smallest sum for now is 91. And then you will consider b being 47 and a smaller than 47. As you have limited that here for AB, it's already equal 91. So for here, you limit a smaller than 44 so that their sum still be smaller than 91. But even if a is 44 and it's 1 over 44 minus 1 over 47, this actually gives you 3 over 2068. This is greater than 1 over 2015. That's a common sense, isn't it? So this also doesn't apply. So for here, we would just know that a plus b, that cannot be smaller than 91. So the least possible sum for the two integers a and b, which we have set for here, the least possible for the other two integers would be 91. So that's it for question 8.